Hi, in this video we're going to be going through the concept of resistance. So the question is, how do you calculate resistance? And like I mentioned in the previous video, you use the equation V equals to IR. But it's not just as simple as that. Let's take a look at resistance in a series circuit. Let's say you have a cell and 3 filament lamps. Okay, and you know from the previous video that voltage is split between these components. And if voltage is split, let's just say for simplicity again, we have 6 volts and this gets 2 volts, 2 volts, 2 volts, assuming that all of these filament lamps are identical, so they have the same resistance. So if the voltage is being split between the components, you know that the sum of all these voltages is equal to the voltage in the cell, right? That applies to other scenarios as well. Let's say you have 6 volts again, a cell with 6 volts, and then this time you have 2 filament lamps. Let's say this gets 4 volts, this gets 2 volts. The sum of the voltages of components in the series is always equal to the voltage of the cell. So let's call this, right? So let's try and derive an equation for resistance from this. Let's call this voltage total, so VT, and this is V1, V2, V3. So now what we can do is we can come up with an equation. VT is equal to V1 plus V2 plus V3. And like it was shown at the start of the video, V is equal to IR. And we know that current in a series circuit is always the same, so we don't need to put like IT, I1, I2, I3. You can just use the same I for all of this. But the resistance may be different. In this scenario, yes, the resistance is the same, but usually, or in a lot of scenarios, resistances are not the same of the filament lamps, and so we're just assuming a general scenario, okay? So VT can just put as I RT is equal to I R1 plus I R2 plus I R3. As you can tell, in all of this there's I, right? And I is equal in everything, right? Because it's a series circuit, so current is the same everywhere. So what we can do is we can divide both sides of the equation by I. And if we divide both sides of the equation by I, we get RT is equal to R1 plus R2 plus R3. So all you're doing is adding the resistances of all of these filament lamps together. So in a series circuit, in order to calculate total resistance, you just add the resistances of the respective components in the series. That's it. Right? So let's just say, let me remove this 2 volts, 2 volt stuff. Okay, assuming you have like what, 3 ohms, 12 ohms, and 2 ohms, just like random, right? So how would you calculate the total resistance? You would calculate it by adding all of these together. So what you would do is 3 ohms plus 12 ohms plus 2 ohms, and that would give you the total resistance, right? And now that's for a series circuit. That is for series, okay? What about parallel? What would we do in a parallel circuit? Okay, now that is a bit different. Let's draw a parallel circuit. And this time I'll make 3 branches, so we have 3 filament lamps. And as we know, in a parallel circuit, the voltage that each of the components in the branches receives is the same as the maximum voltage, right? So let's say if this is 6 volts, then all of these will be 6 volts, 6 volts, 6 volts. And if this was 3 volts, for example, then all of these would be 3 volts, 3 volts, 3 volts. Doesn't matter what the voltage of the cell is, the voltage of each of the branches will be the same, right? So as you know, in a parallel circuit, the voltage is the same. What about the current? What happens is the current splits at a junction. Let's say you have 10 ohms. Now what happens is that each of these 10 ohms will split, right, depending on the ratio of the resistances of the filament lamp. So let's say this just splits into 6 ohms, this splits into 3 ohms, this splits into 1 ohm. Alright, just giving random numbers. But the thing is, the current over oh sorry, I was giving current the unit ohms, it's amps. Okay, so the current over here is also 10 amps. So essentially the current, right, is split at a junction. So this is 6 ohms, right? Then you have why do I keep on saying ohms? Yeah, this is 6 amps. Then you have 4 amps left, and then the 3 amps goes through here, and then the last amp goes through here, and then all of that current is essentially returned at one point, and it's 10 amps in total. So the current in each of these branches adds up to the total current in the circuit. So 6 plus 3 plus 1 is equal to the total current in the circuit, which is 10 amps. So as you can tell, IT is equal to I1 plus I2 plus I3, right? And we know that V is equal to IR. So V over R is equal to I. So let's just do that. And as we know, again, that voltage in each of these is the same, right? Because maximum voltage in each parallel component. So this is V over RT. So you know basically what I'm saying, like similar to current in the last scenario, we don't have to put VT, V1, V2. You can just use V for all of them because it's the same value. So you don't need a different variable. This is V over R1 plus V over R2 plus V over R3. And as you can tell, each of these has the same variable, V. All of them have V in it. So what you can do is divide it by V. So let's say we divide this by V, divide this by V, divided by V, divided by V, and this cancels out, this cancels out, this cancels out, this cancels out, and you're left with 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And that is the equation for resistances in parallel.